need to still polish up and polish off, okay? We have one new concept to learn today. Hi, Joyce. But we need to kind of practice some alternating series first to make sure that you guys are tracking. Yesterday, it was my fault we didn't get a lot done, but today we can get a lot done. So we have endeavor number 19. Endeavor number 19 only proves convergence and divergence of what type of series? Alternating. Does it prove absolute convergence? No. So if it helps you, you might want to go ahead and make a note to yourself. This only proves conditional convergence. The limit as n goes to infinity equaling 0 and the n plus first term being lower than the nth term only proves conditional convergence for an alternating series. Otherwise, if it wasn't alternating, if we were looking at the absolute value, like for the absolute convergence, this does not mean anything, right? This does not mean anything unless it's in the context of alternating series. Okay, so we have that endeavor card. We also have endeavor card number 20 that talked about absolute versus conditional convergence. Conditional convergence is based upon what we saw on the last card, which is shown as if the alternating series converges, but take away the alternator, use all of our old convergence tests, and it diverges. Absolutely convergent if the absolute value converges as well. That brings us to the examples we were working on yesterday. I think we got through 1 and 2. Number 3 we talked about briefly. Let's go ahead and fill them in just so that we get that good practice. Kiddos, how do we analyze number 3? Besides seeing, hey, guess what? It's alternating. Good, so we can say right away it's an alternating series, right? We can say the limit as n goes to infinity of 1 over root n, remember this is just for the alternating series, does equal 0, and
1 over square root n plus 1
good, is for n greater than or equal to 1, which is exactly what we're dealing with. So we can say, according to this, actually, yeah, we'll just do that. We can say conditionally convergent. But we can't just stop there and not even test for absolute, right? How will we test for absolute?
Take the limit of the absolute, see if the absolute value of the series converges.
Good. So let's keep going and say, all right, now it's time for us to go ahead and look at n equals 1 to infinity of the absolute value of negative 1 to the n, all over root n. We're just looking then at 1 over root n, which diverges by what? Yeah.
Can we just write just a sigma as opposed to 1 to infinity? Just to save time.
Sure, just be careful. Sometimes those lower limits mean things, just in general. P equals 1/2, which is less than or equal to 1, right? Do we have enough information to say, therefore, the series is? Good. Good. I don't know what I was trying to say.
Cosine or sine is a alternating series, correct?
Depends. By itself? No.
Oh, okay, sorry. Cosine of pi n would be alternating. Like cosine pi n over n squared.
If you expand the terms, you should be able to see it based on experimentation, but yes, that sounds about right. And I think sine of pi over 2n. Okay, that has number 3. Number 4, you guys were looking at yesterday. What did you guys see for that one? Oh, we already did that one. Absolutely convergent. Number 5, what did you guys do?
conditional convergent.
Would you want us to like see the steps? How?
The limit as n approaches infinity of 1 over square root n plus 3 equals 0.
1 over square root of n plus 3, or it's 1 over square root of n plus 4, I guess, is less than or equal to 1 over square root of n plus 4.
Good.
There would be n
N.
plus 3 and then the plus 1 on the outside, but it's bigger either way.
It'd be n plus 1 plus 3, so n plus 4.
Yeah, that's what I was wondering.
It would be outside the square root.
The 1 would be inside the n, because it's our function notation.
Oh,
That
okay.
makes sense.
I thought so.
Alright.
N is 3, N is 4, N is N plus 1. You know what I mean?
Yeah.
So that's enough for conditional convergence. And what do you guys do in order to show that it was not absolutely convergent?
I did the interval test.
Yeah, I did an integral test.
It wasn't that bad. It was just a use of. Yeah, just make it to the negative 1/2 power and use of it, and life becomes easier.
Yeah, I just thought that you would do n minus 1.
Is that right? Equals infinity
Mm-hmm.
by the integral test, and positive, decreasing, continuous were good on all 3 counts. So therefore, we can say conditionally the series is conditionally convergent. Does that make sense? Fair
Number
enough.
6, right?
How'd you do number 6?
Limit. N plus 1.
Exactly. What do you find from the very get-go?
1. That word as.
Okay.
How about number 7?
Conditional conversion?
Conditional you can see pretty quickly, right?
Mm.
Because you can do your limit to infinity very fast.
It's whatever the plus 1 is greater less than F's value. Yeah, and then.
P series is short for power series, right?
We've not explicitly said yet.
Okay.
Okay. Number 8.
Oh,
You didn't get that far.
That's okay. Let's get it real fast. We're doing a good job.
Shucks. Bad.
Yeah, please get a bit more ready.
What is the plus 1 called?
Minus the end, so where are the ends?
There's 2 N's.
Yeah, so it goes both places.
Why is it important that n equals 2 to infinity?
Oh, because that makes it always decreasing?
Because
N
I
equals
like
1,
1
then
is 0.
So we'd be in trouble if n equals 1, right? How are you guys thinking about the absolute?
I'll go 2.
Okay.
They just let me know. I guess some of her younger sister used to go here, so some of the kids were talking about it yesterday. I just didn't.
I saw on the Redweb, she was your TA. Senior year.
She's a good kid.
Just checking on you.
Thanks, I
Yeah, I knew her sister a lot better. But they interviewed after the first semester, so she doesn't know her anymore. Is this BC?
The little one this year.
Are you in this class?
Yes.
What grade are you in? Gosh, how did you get to be a senior so quick? Did you skip a grade?
No, I didn't.
I have a hard time catching up with some of the students. Now, the rest of you I have in my mind as seniors, but you're like, well, aren't you still in 10th grade? Sorry. I know that's not. Anyway, carry on.
Okay, thank you. See you later, sir.
It's a good class.
It's a fun one.
All fives right here.
Yeah, right?
All
That's what I'm
fives.
telling him.
Good.
Better.
Never mind, this actually works, and I don't know how to
Oh, the integral test works?
Yeah.
Good, because this actually didn't work.
Yeah, because 1 over n doesn't converge, right?
Yeah, I realized.
Yeah, I was gonna go show you.
So it converges to the absolute image.
Where's the Fernever quiz?
Friday.
Those studies?
Wait, when you do like, lucky 7 or whatever,
Oh, you did look the same. I should use U equals ln and D equals ln.
It's gotta be X.
Okay, I wasn't.
You
Then I don't
can-
really have to do anything because then I'm looking at my work.
You
and
can
probably
do-
be able to-
Oh,
you can do N and have it DN.
I know, but he's like, it's not the right. I don't know. Right ratio.
Okay.
Wait,
That's what I asked her. She shot me down, and I was like, dang.
diverges?
Doesn't integral test diverge?
Yeah.
He doesn't. It does divert, but the integral test.
I got a number.
How'd you get a number?
How did you?
Because it's ln of x. That's just
It's so.
1 over ln of b minus 1 over ln of 2, right?
Say it again.
U is equal to ln of x, right? And then du is 1 over x, so I have
Over b.
u to the negative 1, which would be, or 1 over u, yeah, which would be ln of u. So you end up with the limit as b goes to infinity, so we can make that b, ln of b minus
Oh, I forgot my
ln
first one.
of, oh, does that make sense? Ln of 2, right? Double check me though, I did it fast in my head, so I might be wrong.
well, that's what I thought.
So we can say it diverges by the integral test. So then we can say series converges. Now, number 9's easier. Did you guys already get that?
Yeah.
What do you see right away?
Geo.
Uh-huh. So do we even need to worry about the limit as? Why not? Yeah, can't we go directly to here and say n equals 1 to infinity of 1 over 2 to the n converges by geometric series since r equals?
Which is
Oh, I'm so dumb.
-10, -1
I should put close intervals though, should I? Therefore, series converges. Yeah. So see how it's always nice to look really quickly and see if you can do the absolute value? Just because that can shortcut the entire process. Now, what on earth is going on with 10 and 11? Take a second. Can you guys start getting me the first few terms? What if n equals 1? What if n equals 2? Etc. 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 Yeah, what if n equals 1? What if n equals 2? Sometimes, especially on these weird piecewise or even the ones where cosine and sine show up, it might be the best approach to start by thinking, well, what are the first few terms, remember? Easy cheesy? Lemon squeezy?
Can on that last one, can we just say conversion of the geoseries? Wouldn't the second part would be kind of
We don't know if the negative one makes it possible. I think that's what it meant. Is that what you're talking about?
no, like you don't really have to say it converges absolutely. Just saying it converges by the geoseries test.
I don't think you can because of the negative one.
Yeah, but no, but it's on -1 to 1. So if it's -1/2, it's below. It's above -1.
I think the terms would be -1/2, then +1/2, then -1/2, right?
Mm-hmm.
Or not 1/2, but you know what I mean? It would be also into negative positive.
Yeah,
So you have to do the alternate parentheses. That's why.
but then why does it? But then you have to do that for every time the geoseries has a -r.
Not a negative r, but a -1 to the power of n. I don't know.
What are you looking at, Joe? I don't remember that.
Nah, because I did the infinite sum of parentheses -1/2 to the n.
You could do that and say that r is equal to -1/2. You don't even need to worry about it. But you do need to be able to say converges absolutely, which you would not think of saying to a non-alternating series. True?
Yes.
What have you guys gotten for your first few terms?
2.
2, -1, 1, -1/2.
Wait a minute.
Or are you writing them?
A sub n plus 1 less than or equal to a sub n.
I'm confused.
Uh-oh. But they're alternating, right? So what do we do if a sub n plus 1 is not necessarily less than a sub n? You guys looking? Doesn't it go like down and up and down and up and down and up? Can we do this if we're going down and up and down and up and down and up?
I don't think so. Because if you did the nth term test, the loop does not exist.
Just write not possible. Well,
Then it'll be alright. It'll be no big deal.
Yes, it is possible.
Okay.
Trickeries?
Say it one more time. So you have 2, and then what?
-1 and 1 and -1/2. What? Oh man. Oh, I have a question.
It's not telescoping up.
Never mind.
Oh yeah, we.
Oh,
There's a 1/2.
Is it telescoping?
Hey, what?
You have
No,
the
it's-
you have the 1/2.
It is telescoping. Look, n and n plus 1.
Because the 1 cancel out,
God.
and the 2 1/2.
So,
Oh man.
the
No.
telescoping is
Oh. Dang it. Yeah.
Is it perfectly
I
telescoping?
don't think so. I don't know. We need more terms.
What do you see?
The 2 is left over.
With young.
The 2/3 is left over.
Are you sure it's left over?
No,
Almost
it's not.
positive.
Is that not 46?
This is messy, right? Okay, so hold on. Maybe there's another way of looking at it.
Oh, God, the denominator.
Oh no.
What?
It's 1 over n. Son of a stinking goat.
Oh, that's pretty cool.
Oh god. You serious?
That's pretty cool.
What? Oh, dog. Kill that is.
There is a way to do it if A sub n plus 1 is not necessarily less than A sub n, but you're not going to be able to use alternating series. There must be some other way. Maybe telescoping, but it wasn't coming out clearly, was it? So then you've seen me on a telescoping one try grouping pairs together. Is there any way to think of why you should have thought of this? Well, okay, number one, this is advanced, okay? It's rough. But do you also see how I kind of grouped together like terms? The thirds with the thirds, the fourths with the fourths. Well, half they can be fourths, the fifth with the fifths, yeah?
Yes.
And I was seeing what happened. It worked out this way. Other times it might not. There might be some other technique. But, well, that was a little stinky hidden one. Have you guys already started expanding number 11? Let's see what you come up with that one.
How many times should we do?
I don't know. As many until you can find a pattern. It's kind of similar in the pattern. I totally agree with that.
Definitely not 1 over n. There's one, maybe 1/4, 1/3, or maybe 1/16, 1/5, maybe 1/6.
It's not as pretty. It's not as pretty.
What's 16 times 2? What, 32?
Is a sub n plus 1 necessarily less than a sub n? No. Is the second term necessarily lower than the previous? Is it decreasing strictly? No. Have you guys tried grouping them together though?
Yeah, it doesn't really look pretty. It's like 3/4.
Do you have to double group it? Like group it and then from there group it again?
I don't think you double group it per se.
That would be evil if it was.
Just check.
But what do you get? 3/4. What's the next one?
3/4?
The first one's 3/4, right?
What's
1
1
minus
plus
1/4?
negative 1/16?
1 plus negative?
Negative, 1/3, sorry, 1/3 plus.
If you get common denominators, which would be what, 48ths? 3 goes into 48 16 times? 16 minus 3, 13 48ths. Does that sound nice?
No.
No. So maybe we shouldn't think about what simple series it ends up equaling. Maybe we should think instead of how to express the terms that we see. Is there any way to express the terms that we see?
As in like in decimals or like
No, as in formulas.
An alternating series, I guess you could.
Oh, where'd he go?
Bob.
Where'd you go? He disappeared. Let's see if he comes back.
Bob.
There he is.
Did it close by itself?
Oh, it's been doing weird stuff today, don't ask.
Silly programmers. We need to stop drinking coffee.
Okay, so we have 1 minus a fourth plus 1/3 minus 1/16 plus 1/5. What do you guys notice about the first terms in each of these?
They're odd.
Yeah, 1 over 1, 1 over 3, 1 over 5. Right? They're the next odd number. So if we could express 1 over the odds for one term, what can we talk about the second term? What's going on there?
It's 1 over n minus 1 over 2n squared, I think. Like it's a telescoping series possibly.
Close. It's not telescoping per se, 'cause it's going to be 1 over odds, so the 1/4 will never cancel, the 1/16 will never cancel. Can't say it's telescoping. But can't we express this to be, is it n equals 1 to infinity? Yeah. Odd numbers, let's see. How do we get 1 over 1? That's even numbers. How about that? Right? You take an even number and you add 1 or subtract 1. So I need 1 over 1 to start. So plug in 1. 2 times 1 minus 1 would be 1 over 1. 2 times 2 is 4 minus 1 is 3. 2 times 3 is 6 minus 1 is 5. That's the first piece. How do we get the second piece?
1 over 2n, I think.
Okay, let's check it.
No, that'd be 1 over.
That'd be 2, 4, 6, 8. No, that doesn't work.
1 over 4n? Yeah, 1 over 4n.
You said 2n squared. So 2 times 1 squared.
Yeah, no.
Wait, we're doing
Hold
odds
on.
and the even?
This is 1 over 2 to the squared. This is 1 over 2 to the
Oh, maybe it's 1 over
fourth.
4 to the
This
x.
is 1 over 2 to the
1 over
4 to
1
the
over
n.
2 to the n plus 1? No.
What's 4
Yes,
cubed?
1 over 2 to the n
that doesn't work, right? Because is 36 break down into 2s?
plus 1.
No.
I thought it'd be 4 to the n, but it's not. It's wrong.
Wait! 1 over 2 squared, 1 over 4 squared, 1 over 6 squared, 1 over.
Whatever, n squared?
Nope, there's not a 3 squared or a 5 squared or a 7 squared. It's only a 2 squared, a 4 squared, a 6 squared. So we needed even numbers to be squared for the second, and we needed odd numbers for the first. Now, why on earth do I show you that? What on earth can we do with them?
No idea. You can split up the sum, make 2 separate sums. And they both
Oh, we can add them. Get like denominators.
Mm-hmm.
I love Cygnus. Let's Cygnus work right there.
George.
Maybe it's not. I don't know. I never really met a Cygnus.
Maybe you have, you just didn't use it.
Is that right? Common denominators? Multiply the left by 4n squared, multiply the right by 2n minus 1, and add them together.
Whatever you say.
Yes, I think that looks
Does
right.
that make sense though?
Yeah,
I think so.
and then we can agree
Nth term diverges.
that it goes to the limit goes to 0, but I don't know if it's alternating or not. So I don't know.
Wait, can we do a limit comparison test?
Can
Can't we just do n?
Because that's an n squared over an n cubed, so can't we
1 over
do limit comparison?
Wait, is it n cubed or n squared?
N cubed
We're
because
gonna
n
distribute
squared times.
No.
1 over n cubed. Can we do that, or 1 over n? Just 1 over n. Just put it down.
Just one over n.
Yeah, that's what I was thinking. Because the n squared and n cubed we can think
Yeah.
of.
And then we cancel.
So that'd be an 8n cubed minus 4n squared, right? Times n over 1. So we're comparing to.
And then we can factor out n squared. And then, no, tied.
Which diverges by p series. This one ends up being a tie, which will be 1/2, right? Remember what our rule said? As long as we get a non-zero constant, what can we say?
They both same.
Converge or diverge?
They both do the same, so therefore we can say, haha,
Just,
compared to 1 over n, which diverges by p series,
why is this in the alternating series? Just because like the odd and even alternate?
and the signs alternate. So you might think it's a alternating series. I can't. You guys know 1 over n diverges by p series, right? No big deal. So we can say, therefore, our series. It's just showing you that what if it doesn't work with the alternating series test, and the long story short is then you can't use it, you have to use something else. So I'm just trying to give you a couple, hey, they alternate, wait, there's something else we're supposed to do because the test fails because the terms don't decrease. Does that make sense?
Question.
Answer.
How are we supposed to just figure out that formula?
You're not necessarily, that's why these are examples, but I'm trying to show you there are alternating series out there that can be seen a different way. And the hint is, Gerardo, could the alternating test work? No, because the terms don't decrease. So you guys yesterday were like, no, the terms will always decrease. Well,
Not necessarily.
not necessarily. If it's going kind of back and forth. Now these are piecewise functions, of course, but I was just trying to give you some exposure to non-always decreasing. Long story short, you don't need to write all this stuff down. Long story short, this is saying there's 2 different approaches as to how you go about doing alternating series. We don't need to necessarily stress too much about that, except I did like at least showing you guys what they said was, hey, based on all this craziness, a good way of testing an alternating series, check the nth term for divergence, aka the limit z goes to infinity, which we have been doing. Of course, if it is non-zero, then it just diverges. Then if it is 0, go ahead and apply the alternating test, aka the a sub n plus 1 is less than a sub n, etc., etc., etc. But that's not a big deal, because I think, guys, practice makes perfect. I think you've gotten an approach based on all the practice that we've done. So let's move on past testing alternating series for convergence and divergence, and let's talk about the last big idea of section 9.5. The last big idea, and he is an important one. He's like an AP important one. Estimating and alternating, right?
Alternate series?
I don't like alternate. Isn't alternating?
It's also doing.
You call them alternate series.
I know. Here, let me just erase that.
Unless you're saying there's another type of series.
Yeah, no, it doesn't mean that. I think I just misspelled it when I was doing the notes.
Is this one exactly copied on our paper?
Yes, please.
Which isn't
Oh, you mean in your forever card? Endeavor card?
No, I mean like on the handout. Is it because the other
It
ones?
should be.
Because the other ones weren't like exact copies.
Should be.
the nth term one that really has it's like if and then comma. And it doesn't say like the
Yeah.
That's a little too thick. And this is endeavor number 21.
That's not
Alternating series estimation theorem. If the alternating series converges, the alternating, so it doesn't have to be absolutely convergent. If the alternating itself converges, then the truncation error, well, the nth partial sum, you're only adding together a certain finite number of sums, so you're missing the rest of the story. You're missing the rest of the sum. You're having some truncation error because you're cutting off the rest. The truncation error for the nth partial sum is less than a sub n plus 1, or the n plus first term. Meaning, if an alternating series converges, then the error in estimating the sum using n terms is less than the n plus first term. And just for sake of clarification, let me go ahead and throw in some parentheses in there. This technically should be the n plus first term like that. What does R stand for? Remainder. How do you find the remainder? Take the actual minus the approximate. So instead of the infinite sum, the sum of the finite number of terms, the actual minus the approximate will be less than or equal to the next term. So if you find the sixth partial sum, the error will be less than the seventh partial sum. And if you think about alternating series, if we were figuring out that it converges, then we can say it's a decreasing series, right? A sub n plus 1 is less than or equal to a sub n. If you think about you're always adding smaller and smaller terms, maybe it makes sense that the error will be less than or equal to alternating back and forth, adding, subtracting, will be less than just the next term itself.
Why is it all absolute value?
Because we don't know if it starts with a positive then a negative or a negative then a positive, so we don't want to necessarily talk about the sign. We want to ignore the sign altogether. We're looking at, in a sense, the magnitude, as in how far away it is, not necessarily whether it's a positive or negative away. Does that make sense?
You know the ways we ignore signs in calculus, Miss Steve? Is there a way of applying that to stop signs and traffic signs?
No, good try.
Are you? Stop sign is just suggestion.
Okay, so as we've already seen, as you guys can kind of tell before, I tried to label it just to make it a little bit easier. But the sum is the entire infinite sum. Partial sum is just an approximation, right? The error is called the remainder. You can see it both ways in the AP, and the error is found by subtracting the actual minus the approximate. We don't know the actual. And we will only know it if someone tells it to us and use instruments to find it. We don't know the actual. But we do, or we can find the nth sum, the nth partial sum. It keeps talking about why it makes sense that the error would be less than the next term. Bottom line, You can get an idea of how close you are with your nth partial sum without ever actually knowing the sum itself, which is pretty stinking cool. So, example, zoom in. Thank you. And this is where your note packet starts being helpful because you don't want to write all these words. Given the convergent alternating series. Ooh, convergent? What? They told it to us.
How nice.
Estimate the sum of the series by taking the first 5 terms. How accurate is this estimate? How accurate is this estimate? Well, hold on. How do we find this? How do we estimate with the first 5 terms?
Just do n to the 1 to the power to the fifth.
So s sub 5, or the 5th partial sum, is going to equal 1 minus a half plus a third minus a fourth. 5th partial sum, we need to go one more, right? That's going to end up being a half. Let's see, what's the common denominator between 2 and 3 and 4 and 5?
Well, we could do
16. So we could do 30 sixtieths plus 20 sixtieths minus 15 sixtieths plus 12 sixtieths. And what do we get?
20, 50, 65, 77,
Almost.
10.
50 minus 3.
5, subtract. I added this.
Okay, so that's our estimation. 47 sixtieths, that's our 5th partial sum, right? Which is approximately, if we were to do it as a decimal, oh, I actually have it right here. 0.78333333, dot, dot, dot. How accurate? Oh, I just have it on my paper because I already solved it. You're welcome.
Yeah.
How accurate is this estimate? Meaning I do decimals in my head. How accurate, just kidding, is this estimate? Wait a minute. This estimate, meaning s minus s sub 5, is going to be less than or equal to who?
8, 7%.
And if we stopped at the 5th, then it must be the 6th term, right? So what can we say about that? How accurate? S minus s sub 5. Who is the 6th term, guys? Negative 1/6, but we don't care about the negative. We just say it's going to be less than 1/6. Does that make sense?
Yeah.
Now, hold on. We can get even better than that because we can say S minus our 47 over 60 is less than or equal to, greater than or equal to. It's somewhere between negative 1/6 and 1/6 based on absolute value. And then question, can't we solve by adding 47 sixtieths and get an approximation for our sum? A range that is only going to be 1/6 off. Alright, cool kids. On your homework, work on everything to do with convergence and divergence of alternating series. But we'll practice a little bit more of the remainder things tomorrow.